Welcome to Tech Prep video tutorials. In chemistry, the question asked is when a protein has been isolated as sodium salt with their molecular formula as Na of Xp. This notation means that ions are associated with a negatively charged protein. So a solution of this salt was prepared by dissolving 0.25 grams of this sodium salt of protein in 10 grams of water, which means 0.25 grams of this salt was dissolved in 10 grams of water, and Azeotropic analysis reveals that the solution boils at 5.93 into 10 to the power minus 3 degrees centigrade, higher than normal boiling point of water, which is just slightly higher than the boiling point of water. We have also been given the boiling constant K of water is 0.52 kilos per mole, and also elemental analysis reveals that the salt contains 1% sodium metal by weight. So what is the molecular weight of acidic form of protein HXP? So the trick here would be to find the molecular weight of the of NaXP, the sodium protein, and then deduct when as the solution gets prepared, the sodium is replaced by the hydrogen molecule to give it the acidic form. So when we get to know the total molecular weight of NaXP and remove it from the total solution, we arrive at the molecular weight of the acidic form of protein HXP. So let's look at what are the options given. So there are four big values given. Let's see how we can solve this question from the data given. So let's assume that the molecular weight of the NaXP equals to capital M, and the moles of NaXP would be 0.25 grams, which we started off with, by M. Since NaXP will dissociate into the ions, so 1 mole of NaXP will always be equal to 1 plus X moles, because it's getting dissociated in the solution. So the total moles in the solution, of the salt in the solution would be 0.25 by M into 1 plus X. And we also know from the formula that the temperature at boiling, the difference of temperature at boiling point is equal to the constant given at boiling point into the molecular weight of the total solution. When we replace the values of temperature difference, the constant given 0.52, and what we have arrived at, which is the total molecular weight of the solution by 10, which is the 10 grams which has been used, and find out how much does it come up to in a liter. On simplification, we arrived that 1 plus X by M equals to a value 4.56 into 10 to the power of minus 4. Let's take that as equation 1. The other piece of information given is that the salt contains 1% of the metal by weight. So capital M into 0.01, which is the 1%, should be equal to 23, which is the molecular weight of sodium, times X. So X, we arrive at a second equation where X by M is equals to 0.01 by 23. Now see at the question 1 and question 2. The question 1 can be also said as it's equals 1 by m plus x by m equals 4.56 into 10 to the power of minus 4. So we know that x by m value, replacing the value we have found in equation 2 in equation 1. Let's see what we arrive at. Now let's reverse the equation. We arrive m as 46792, which is the complete weight of the solution. So we know when we replace the values of m into the equation 2, we get to the value of x equals 0.01 by 23 into 46792, which is approximately equal to 20. So the molecular formula of the protein would be Na20P, and the total molecular weight is 46792. So what is the molecular weight of Na20P? It would be 46792 minus 23 into 20, because we are having 20 atoms of sodium, plus the protein into 20, we arrive 46352. Since the sodium is getting replaced, we did reduce it from the molecular weight, and we arrive at the answer. So the right answer, which is the molecular weight of the acidic form of the protein, is 46352, and the right answer is option D.